So we've been using Kubernetes. We have pods and we control those pods using deployments or daemon sets or stateful sets. We have configs and secrets. We load balance our pods using services. We wrap all this infrastructure up into Helm charts, and we expose our pods to the internet and to outside of our clusters using what's called an ingress. Now you may or may not know, but there is a new kid on the block. People like to think of it as Ingress v2. Now what is that? Back in 2023, there was an announcement for Kubernetes about a new product or component called the Gateway API. And today is just an informative video where we'll be talking about what the Gateway API is, why it exists, the challenges it solves. I'll show you a quick working demo so you get the overview of how it's used, and stick around till the end of the video so you can hear my final thoughts. Does it mean that Ingress is dead? Is this the new Ingress or the new future? Stick around. So up until now, we should all be familiar with an ingress. What is a Kubernetes ingress? Well, it's an object in Kubernetes where we describe how we want our traffic to come into our cluster and how do we want our services that are exposing our pods to be exposed to the internet. So for an example, we have a domain like this domain over here. The domain has TLS support. This domain will translate to a public IP address, which would be something like a load balancer if you're running in the cloud or some kind of network device. The ingress object basically defines which domain and which path will route to which service on the back end. It also allows us to specify things like TLS certificates, or whether we want TLS terminated, or whether we want to pass through TLS. Behind the scenes, the ingress is managed by what's called an ingress controller, and there are many types of ingress controllers out there. So far, when you need an ingress controller in your cluster, you must have looked at Helm charts and looked at potentially using something like Traffic or Nginx. If you're running on Microsoft Azure or AWS, they might have an ingress solution for you. So you generally bring your own controller, and all of these controllers conform to a standard which is called Ingress, and you define that ingress as a YAML file stating the rules at which the cluster will accept traffic coming in and where it will forward that traffic to. And using an ingress, you should be familiar with this YAML file. This is what an ingress looks like. It's part of the Kubernetes networking API. Its kind is ingress. It has a name and it has annotations. The ingress is very useful because everything about how the traffic is treated that comes in is defined here. You can see we have a class name stating that we want this ingress to be taken care of by the Nginx ingress controller. We have TLS certificate for this specific domain. We tell it where to find the TLS secret, and then we have rules about how to treat the traffic. So anything coming over this host with this specific path will route to this backend called service A on this port, which is port 80. You can also see I have some annotations here that adds basic authentication to this service. So there are a couple of challenges that companies have faced by using ingress. The ingress object has a lot of control about the traffic coming in. And for some companies, this works just fine. But let's take a look at some of the flaws. The first thing is annotations. If you're familiar with ingress controllers, every ingress controller has a bunch of its own features. There are basic things that proxies need to be able to do. Some is basic authentication, OAuth authentication support, rewriting URLs, things like supporting CORS, cross-origin requests, which leads into a bunch of security features, things like blue, green, and canary deployments. The ingress controllers try to do a lot, and there's a lot of support if you take a look at the rules about how traffic can be routed, but there's also a lot missing. In this example, I have basic auth. Now, this is supported by the Nginx ingress controller through annotations. This means that the community that's responsible for building the Nginx ingress controller need to allow for these interfaces. They actually need to write code and do all sorts of things and magic to allow us to be able to put these annotations in place. And there is actually a huge list of these features. Now, these features are good, but there's always trade-offs. The first trade-off is that all of these annotations are Nginx specific. This means if I want to move to another product, it's going to be really hard for me to do so. So there's a lot of vendor lock-in here to Nginx. And there might be a feature on another type of proxy, like HA proxy or traffic or something that I might be interested in, but I can't move because certain things are locked to Nginx. And it just makes it really hard to move in other cases. Nginx is extremely powerful, and there are even Lua script snippet capabilities where you can customize almost every aspect of the traffic, and you can do a lot of magic. So that is the first challenge. The second one is more of a challenge from a security focus, is that TLS secrets are exposed here. This means that I have to have the reference of the TLS certificate within my Ingress, and it means that the TLS certificate needs to live in the same namespace as where the Ingress live, and generally the Ingress will need to live in the same namespace where the developer's pods live. Now, for smaller and more lean teams, it is easy to manage this using Kubernetes RBAC to some degree. But when you're working for a larger organization where there's a lot of things around governance and security and policies, it becomes difficult to make everyone satisfied. So this is another challenge. Ingress kind of lacks cross namespace support for these types of things. I cannot move the certificate into another namespace. Now, certain Ingress controllers allow you to pick up certs and they have their own certificate stores, but again, this would be specific to that Ingress controller. The other thing here is that all traffic is allowed. So once I deploy this Ingress, any traffic that comes in over this domain and path combination will be accepted. It's hard to exactly govern what traffic is allowed here unless I use a network policy. But if I do use a network policy, then that means the clients that I block cannot use the Ingress controller at all, because network policies is an all or nothing rule. So it becomes difficult for me to expose path A to some services but not to others, and path B to certain services and not others. So there are a lack of traffic policies within this sort of design, and also a lack of modularity, which is something I'll show you in a little bit. We're not able to break up these objects into smaller objects and give them each their own permissions and have different teams look after and govern them. Now, for someone who's been using Ingress for years, I'm pretty happy with it, but I can see the need for more modularity, for breaking up the Ingress object into multiple components so that we can have certain permissions on these components and not expose everything. One of the challenges is that different Ingress controllers were going on their own missions to solve certain challenges, again leading to more annotations and custom features which would vendor lock you into that Ingress solution. A lot of people were solving some of these challenges by moving into what's called a service mesh. If you've used a product like Istio, it's got virtual service capability, and this service has canary deployments, blue-green deployments, and all sorts of features. But as far as I understand, the same challenges existed there. And it meant that open source products were moving into their own directions to solve certain needs for governance, compliance, security, and development needs. And if you take a step back and you think of Kubernetes, Kubernetes should be declarative. You don't want to live in a world where you install a lot of custom features. Think of pods, deployments, secrets, services, config maps, and all those objects. They conform to standards, and we can use that to deploy microservices, jobs, we can deploy databases, caches, message queues. All of these wonderful open source tools can be deployed with these standard objects. So it would be nice if we can solve these sort of Ingress issues with standard Kubernetes objects. And this is where the Gateway API comes in. So if you look at the overall picture, the Gateway API resembles a lot of known components that we are used to with Ingress. So we still have traffic coming from the outside, over a domain and over TLS. It comes to the same thing like a load balancer in your cluster. But in this case, instead of deploying one Ingress object, this thing has been broken up into multiple objects that we'll need to understand. Firstly, let's start with the gateway class. The gateway class is the thing that tells us what feature our cluster has access to when it comes to gateway traffic or Ingress traffic. So the gateway class will tell us what sort of proxy or API gateway software we have access to. Similar to how we would say we have an Ingress controller and it's of type Nginx, or it's HA proxy, or it's Kong, or it's traffic. We can have multiple gateway classes deployed to our cluster. I would almost view this similarly to the Ingress class that we have with Ingress. Now, the gateway class allows us to have this sort of governed by infrastructure or cloud teams. So if you're deploying to something like AKS, then Microsoft could provide you with a gateway class that uses their API gateway or their Azure front end. Or you could define a gateway class in Amazon AWS on an EKS cluster, which gives you load balancing capabilities with their software, like the AWS API gateway. And this is what the gateway class looks like. It's a very simple YAML and it doesn't need a namespace. It's actually a global type object. You deploy it to your cluster and then you give it a name. And in my example, I'm just going to use traffic. And then I basically specify this controller name to say who is in charge of this gateway class. So this controller needs to be running in my cluster. And this controller will basically be managing gateway objects that we will be creating that point to this gateway class. This means I can have any type of API gateway running. Then the next object we have now is called a gateway. So think of the gateway almost as an Ingress rule, but it is the rule that governs all the different routes that we'll have, like paths and domain combinations. It'll also govern things like the TLS certificates that we want to specify. The gateway object is also namespaced, so we can place it in the same namespace where the teams are running their pods and services, or it can be living in other namespaces. So that is what's quite unique with this new gateway API, is that these objects can actually live across namespaces. So the gateway class is global, and that can be consumed by gateway objects, which can live in any namespace. So the gateway object is basically in charge of all the certificates and information about our gateway that developers will consume. So some of the governance will be living on the gateway object. So this is an example gateway. The gateway lives in a namespace. So in my case, I'm just using the default namespace as a test. And then I point to the gateway class I want to use, and I create a bunch of listeners. And the listeners are basically just going to be listening on ports. So I will expose ports. So this is example, just port 8000. And you can see you can have listeners like HTTPS listening on port 443. You can terminate TLS or pass it through. And here is the certificate reference. So I can actually point this gateway to a certificate for TLS that lives in a different namespace. So this allows us to have our TLS certificates in namespaces where other teams do not have access to. And the gateway objects can refer to those secrets across namespaces. So we'll have RBAC and namespaces at which we can protect things. And then you have things like allowed routes, and we'll talk about routes in a bit. So this gateway object basically allows us to set up scenarios where we can share load balancers, or we can have different load balancers consumed by different teams. We can also control what ports are exposed coming into our cluster, whether it's HTTP, UDP, TCP, or gRPC, and all the things we'll be defining in a route. Now, as you can see, all of these things are generally infrastructure concerns, like load balancers, the ports that are exposed, where the TLS is supported, where the certificates lie, and all of that. This means the gateway object will help us lock down, from a security point of view, infrastructure related things for our cluster. So it separates concerns a little bit. So that's the gateway class and gateway. The next important object with gateway API is called the routes. Now, previously routes were exposed by an Ingress object. Technically, all of the things we're looking at here was in one object, where now things are being separated based on certain concerns. Now, routes have different features, as you can see in my diagram. One example is things like weighted load balancing. balancing. All of the things we used to see in our Ingress annotations don't have to live in annotations anymore. This will force the products that want to use the Gateway API to conform to the standards. So here we have a standard for HTTP route, which will basically allow unencrypted HTTP traffic. We have TLS route, which is basically TLS or HTTPS traffic. We have TCP and UDP routes. Previously with Ingress, TCP and UDP weren't standards. They always had to be supported by certain controllers only. There's also another route called gRPC, and there may be more routes in the future, but one cool thing with routes is that you can specify as a developer that I want different load balancing weights on my server. So I can do something like a canary deployment in this example. I can make my TLS route a weight of 9 and send it to this top service over here, and I can set a weight of 1 to a new service, basically doing something like a canary deployment as an example. And this brings us to what I think is the overall intent of the Gateway API, which is modularity. As you can see, we have infrastructure providers which basically take care of this gateway class and provide the controllers that are capable of taking in traffic. We have cluster operators who might be teams that only take care of the Kubernetes clusters themselves, and they would provide the gateways. The gateways would then have configurations on the listeners, what ports to expose, which load balancers to use, and where to find TLS certificates. And you can have governance on the gateway of what routes are consumed and which applications and which namespaces are allowed to use the gateway. So you got all this fine-grained governance. And then you have app developers down here, which are responsible for their pods and their services, and they can decide how traffic should be sent to them. So they can say, I want this domain and path to come to my application. And we've taken away the concern points like the TLS certificate. The developers do not need to concern themselves with which TLS certificate is used and where that lives. And this means because these objects are split, you can define different RBAC rules to protect and secure them and expose them to the right teams. So I have this Kubernetes cluster running Kubernetes 1.23 using a product called Kind. It's a simple one-node Kubernetes cluster I can use for testing. Now, as of the time of this recording, Kubernetes doesn't actually support gateway class, and all these resources. We have to go and deploy these CRDs. I believe this might be part of Kubernetes in the future. There's actually a GitHub repo under the Kubernetes Special Interest group called Gateway API, and under here is a releases section, and all the versions are tagged. I can deploy those CRDs straight to my cluster by pointing to the latest release, which is 1.2.1 in that GitHub repo, and I can apply that using kubectl apply -k. Now I actually have these custom resource definitions, so I have gateway class and I got these routes. This will give me access to gateway classes, so I can say kubectl get gateway class, get gateway, get HTTP route, and so forth. And next up, to support Gateway API, you're going to need a Gateway API controller, similar to how we did with Ingress, where you needed an Ingress controller. In this example, I'm going to use traffic. So I say helm install traffic. I'm going to install the latest version into the traffic namespace. And I specifically say that I want the Kubernetes gateway provider to be enabled and give me access logs as well. So I go ahead and do this. This will install it to my cluster. And in the traffic namespace, I can say get pods, and we can see we have a pod running. And after some time, it's ready. I also have a service, and similar to the Ingress controllers, it'll also be a type load balancer service by default. And because I'm running Kind, we don't have an external IP. So what I'll do is I'll just set up a host file and I'll use port forward. With port forward running, I can go ahead and send traffic to this controller. I can see the logs of my traffic controller, and we can see it's now running. Then I can go ahead and deploy my gateway class. After my gateway class is deployed, I can go ahead and deploy my gateway. Then to get some applications running, I can say kubectl apply and deploy our deployment.yaml that we've used in previous videos. That'll give us a deployment with a few pods. I can deploy a service to expose those pods. If I say kubectl get pods, you can see we have our example app here. If I say kubectl get service, we now have example service exposed here. And that brings us to the route. So the route is the thing that the developer defines, as I mentioned before, and they'll define what host name and what path comes to what service. So they have control over their traffic, and you'll notice here that there's no information about the TLS certificate, so some things have been abstracted away. And as a developer, I can just say that I want an HTTP route, this is the name of it, it's in this namespace. I want to be using our traffic gateway so that developers can then consume the gateway without having access to the gateway directly. And then I say, I want my hostname exampleapp.com on this path to go to my example app service. And I can even specify a wait, so I can do canary deployments if I wanted to. So I then go ahead and apply that YAML, and that'll give me the path. And with port forward still running, I can go ahead and test that. With the host file set for this domain, because the domain doesn't actually exist, I can say exampleapp.com in the browser, and you can see we've hit our application. I can rerun that command to get the logs, and we can see now with our access logs enabled, we are getting the traffic. So those are the overall design principles and features of Gateway API. You can see it's very similar to Ingress. So do I think that Ingress is dead? Now, to be honest, I don't think Gateway API will replace Ingress at all. For small or medium businesses with maybe some lean engineering teams, Ingress is very sufficient and very powerful, and it's also very easy to manage. Some teams may not have these concerns with modularity. In many companies, they have developers who write code and build stuff, and then they have engineers who look after stuff. So look after infrastructure like Kubernetes clusters and manage all the YAML and all of that, and assist with setting up pipelines and monitoring pipelines. And in that model, all the routing rules are configured in one place called the Ingress. So it's very powerful, it's very convenient, it's all in one place, it's very easy to understand and learn, and it's capable of doing it all. So why change it? But I can also see a world where you have larger organizations who have larger distributed teams, not just developers and operations, but also security and SecOps focused teams, networking teams, infrastructure teams, compliance and governance teams, SREs, DevOps engineers. And in a world like that where you need more granular control over things, and policies and governance, a modular design of the Gateway API may be more suitable. It's because these larger organizations generally have a lot more compliance needs to meet, and they have a lot more people who take care of smaller aspects of infrastructure. So I think thinking of Gateway API as Ingress v2 is probably not correct, because if you think of it as v2, then you're implying that v1 is no longer going to be needed. And I don't see that happening given the state of current Ingress and the investments that companies have already made in Ingress. There is a lot of vendor locking in the Ingress solutions currently. I don't think it's easy for companies just to shift. Ingresses like Nginx have a ton of Lua capabilities, and I just don't see a big shift towards Gateway API. My personal opinion is that Ingress will remain the Kubernetes reverse proxy feature because it's pretty good as acting as a basic and advanced reverse proxy. I do see Gateway API as becoming a API gateway framework as a service in Kubernetes. And we know there is quite a big difference between API gateways and reverse proxies. So I see a world where both will thrive. What are your thoughts? Let me know down in the comments below. Have you tried out Gateway API? What do you think of it? What are the challenges you are facing? And what is your experience with it? If you liked the video, be sure to like and subscribe, hit the bell, and check out the link below to the development of the Ultimate DevOps course. And if you want to support the channel even further, be sure to hit the join button down below and become a YouTube member. And as always, thanks for watching, and until next time, peace.